The geometric distribution is similar to the binomial distribution. We can look at the conditions first. Number one, each trial is either a success or failure. That was just like the binomial distribution. Number two, each trial has a constant probability of success. And three, each trial is independent of other trials. So the first three conditions are the same as the binomial distribution. The difference is what we're looking for. In the geometric distribution, we're going to perform trials until we get our first success. Or if you remember, in the binomial distribution, we had a set number of trials. Say we were going to flip a coin 10 times. We already knew from the beginning we were going to flip it 10 times. We were going to count the number of successes. But in the geometric distribution, we're going to perform trials until we get our first success. We'll look at an example here. Okay. And it says, Kobe Bryant is an 85% career free throw shooter. Assume that the probability that he makes any free throw is 0.85 and that shots are independent. If he plans on shooting until he makes a shot, so making a shot is our success in this example, and there's an 85% chance of success on any shot. What is the probability he shoots 2 shots? So understanding what the geometric distribution means. If he's going to shoot 2 shots, he's always going to stop on a success. So he's going to make the second shot. He's going to miss the first shot. It's the only way he can shoot. If he's going to shoot until he misses, or shoot until he makes one, that's the only sequence that we can have here. Okay, so we can get the probability of this exact sequence. He misses the first shot, and there's a 15% chance that he misses the first shot. That's the complement of 85%. 1 minus 0.85 is 0.15. And then he makes the second shot. And that's our probability. Okay, that's the geometric distribution. Understanding that we had to end on a success. So we'll get our probability here, and we'll also, just like we did with binomial distribution, we'll show how to do it in the calculator. So we have 0.15 times 0.85, and that's our answer. Okay. Now, if we do this through second distributions, that's second distributions, we go down to the very bottom, we have geometric PDF and geometric CDF, just like with binomial. So this is a geometric PDF because it's getting the probability of shooting exactly 2 shots. So our P is 0.85, and our X value, which is how many shots we're going to shoot, is 2. It's exactly 2. Notice we don't have an N with the geometric because we don't have a set number of trials from the beginning of the problem. So we run that and we get our answer like that too. Okay. So let's move on to another example. Same setup. It says if he plans on shooting until he makes a shot, what is the probability he shoots less than 3 shots? So again, we're kind of testing our wording here. Less than 3 shots, what does that mean? That means 1 or 2. He either shoots 1 shot or he shoots 2 shots. Notice that he can't shoot 0 shots. We had 0 for the binomial distribution, but 0 doesn't make sense in the geometric distribution. This is the first try. He gets his first success on the first try. He gets his first success on the second try. So understanding his probability. What's the probability he gets his first success on the first try? Well, that's an 85% chance. He's got an 85% chance of making any shot. So on that first shot, he's got an 85% chance. He either can get it on the first try or, notice I say or because I'm going to add these 2 probabilities, or the second try. Well, what's the probability he makes it on the second try? We've actually already computed that. That is a miss and then a make. So we'll understand what has to happen here. He can either make it on the first or miss it on the first and then make it on the second. And that's the only ways he can shoot less than 3 shots. So we'll check that with our calculator. We have 0.85 plus 0.15 times 0.85. We get that answer. Okay. Notice I didn't need parentheses there because it's automatically going to multiply first and then add second. So I can check that. This is now geometric CDF. And remember, just like binomial, geometric CDF means that or less. So if I'm getting 1 or 2, then I want 2 or less, which is the same thing as less than 3. So my x value is going to be 2 here. So geometric CDF, my probability hasn't changed. It's still 0.85. That's the probability of a success. My x value is 2. Because I'm doing CDF, that gives me 2 or less, which is 2 and 1. And I should get the same answer. And we do. Okay? So let's look at another example. Same example, but let's look at another problem. He's still shooting until he makes a shot, so that's still our success. What is the probability he shoots more than one shot? So if he shoots more than one shot, that's either shooting 2 shots or 3 shots or 4 shots or 5 shots and on. There's no upper bound here. So remember, when we don't have an upper bound, we have to do a trick in the calculator. We have to subtract, because the calculator will always go to the left. Okay? In other words, that or less. It won't do that or more. So what we want is 2 or more. That's the same thing as more than 1. So, but if we think about this situation logically, if he shoots more than one shot, then that means he does not make his first shot. He misses his first shot. Okay, if he shoots more, it means he either gets it on the second, he gets his first make on the second, the third, fourth, so forth. So the only thing that's not included in that is, alright, what has to happen before that is he has to miss his first shot. So our answer here is 0.15. So let's take a look at this with the calculator, because probably most of us will be familiar with using this calculator and working problems like this. So let's go to geometric CDF. There's an 85% chance of success. Now we really want 2, 3, 4, 5, and so on. So what we're going to do is do the opposite of that, because we can't do the upper bound. So we have to do the exact opposite of more than 1. The exact opposite of more than 1 is 1 or less. Well, this is 1 or less, which really, geometric CDF of 1 is the same thing as geometric PDF of 1, because there is nothing less than 1. So if we get that answer, we're going to subtract that from 1. We subtract 1 minus 0.85, and we get our 0.15, which is the same as the probability he misses the first free throw. Okay. And probably that'll make a little more sense once we look at another example with another more than probability. So this says if he plans on shooting until he makes a shot, same scenario, what is the probability he shoots between 1 and 4 shots? Now it doesn't say whether that's inclusively or exclusively, but we'll assume that it's inclusively, which means we include 1 and 4. So what's the probability he shoots 1 shot? That would be he's got to make the first shot. What's the probability he shoots exactly 2 shots? He's got to miss the first and make the second. What's the probability he makes his first shot, or he shoots 3 shots? He's got to miss twice. Miss, miss, and I'm going to indicate that like that. Miss, miss, and then make. Or he could shoot 4 shots, which would be miss, 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 and finally a make, which that'd be miss, 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 finally a make. Okay? I guess I can. So, we have 0.85 plus 0.15 times 0.85 plus 0.15 squared times 0.85 plus 0.15 cubed times 0.85. Oh. Times 0.85. So get that answer. And the way we do this in the calculator, which this problem doesn't come up very often, but it's just getting us to understand what the calculator is doing. If you want 1 and 4, if you do geometric CDF, and you want 1, 2, 3, and 4. So if you take, well, actually for this problem, you want 1, 2, 3, and 4. That's actually 4 or less. Okay, 4 or less is 4, 3, 2, or 1, which is what we get. Now, if you had to do between 2 and 4, then you would have to subtract off the probability of getting 1. So in this case, we can do it with just one try. So this is our answer. Okay. So do a couple more. This time, notice same scenario, but he's going to shoot until he misses. So now a success is him missing, which has a probability of 0.15. Okay. So what is the probability he shoots 3 shots? If he's going to shoot 3 shots, he's got to make, miss. So make, it's 2 of those, and then finally he's going to miss. So you could check that in the calculator. Well, I'll do 1. So we have 0.85 squared times 0.15, and that is the same thing as our probability where our success is 0.15, as our success is him missing, and we want 3, shooting exactly 3 shots. I did CDF. So CDF I needed to be PDF. Want exactly 3, not 3 or less. That's why our answer wasn't right there. So 0.15, 3, and that's your answer. Okay. So we'll do a couple maybe without the calculator. So if he plans on shooting until he misses a shot, again our success is miss, which is 0.15. What is the probability he shoots no more than 3 shots? So what does no more than 3 mean? It means exactly what it says, not more than 3. So 1, 2, or 3. I even write that here. 1, 2, 3. So what's the probability he shoots exactly 1 shot to miss? As he misses on the first try. What's the probability he shoots 2 shots until he gets a miss? That would be a make, and then a miss. Or 3 shots would be 2 makes and then a miss. And again, you could check it in your calculator. Your P is 0.15. You want CDF. No more than 3 means 3 or less. So you would do CDF. Your X value would be 3. 3, 2, and 1. And you should get the same thing as this probability calculation here. Okay. Just some more practice with the wording here. What is the probability he shoots at least 3? Now, a lot of people see the word least or at least, and they think that that means less, but at least means that or more. Okay, so at least 3 means 3, 4, 5. There's no upper bound here. Okay, so the way we have to do it, well, there's actually a couple of ways that we can do it here. We could add up the probability of 1 and 2, and then subtract that from 1, which is what we'll have to do in the calculator. Okay. Or you could say, so maybe I'll do it both ways by hand, and then we'll check it in the calculator. So if you have to shoot at least 3 shots before you make one, and that means, this is the, I guess I call the logical way of thinking about it. It's the easiest, it's the shortest steps, but some people have trouble thinking about why it is. You have to miss the first 2 shots. If you got to shoot at least 3 shots, you got to miss the first. Or no, you got to make the first 2 shots because we're trying to get a miss here. If it takes you at least 3 shots to miss, you got to make the first 2 shots. And really, that's our final answer. So if you understand where that comes from, then you're good on this problem. But if not, then we could say, well, we could do 1 minus the probability that we get a 1 or a 2. Probability we get our first success on the first or the second. So that would be the first, miss the first one, or we can make the first and miss the second. So we'll show this, and then I'll also show it in the calculator. Okay, so our answer is 0.85 squared. That's our answer. Or you could do 1 minus 0.15 plus 0.85 times 0.15. That gives us that. Or, in the calculator, we can do basically what we're doing here, but the calculator can do this pretty quickly with geometric CDF. So I can say my probability of success is 0.15. I want to get 2 or less as my X value. 2 or less, which is the opposite of what I actually want. I want 3 or more. But if I get 2 or less, because the calculator will only give you to the left, then I can subtract my answer from 1 and I'll get the same answer. So I get that. Could have did that one step, but 1 minus that is 0.7225. And that's it.